Okay, so practice test out. We did the first page yesterday. That was basically 1 through 7, but it's just the first 4 questions or whatever it is. All right, we're starting with the next page. So we're starting here. We're going to work our way to the end. I'll explain like all this weird stuff off to the side. All right, so 8, 9, and 10. It's all based on the same questions using that stuff up above. What they want you to do is plug it into the function that's provided to you and then simplify it. So like, for instance, you're taking the function I'm giving you up here and you're plugging this mess into it, okay? So for number 8, you're plugging in a 2 plus h into all the spots where there's x's, right? So on this number 8, this is what you're doing. You're taking out the original function, this is the original, right? And in every spot where there's x's, notice they're missing, I'm plugging a 2 plus h into those spots. Does that make sense, like what I'm doing? Then I want you to simplify that answer. So you need to like FOIL, distribute, add like terms. That's how you do number 8. So it will take you a little bit of time. I know I didn't give you a lot of space. Usually like the number 8 takes a little bit of time, and then
You got a FOIL on that one?
Yeah, you'll have to FOIL. So you're gonna have to write the 2 parentheses. You can't distribute the power of 2. You have to write out 2 parentheses. Don't FOIL that, or don't distribute the power of 2. You have to write it like this and then go from there, right? So you have to FOIL these out. Okay, so usually the first one, number 8, takes the longest. It does. 9 and 10 don't, because 9 and 10 are some easy calculation, and then 10 is where you're just combining the 2 answers together. What I mean by that is, let's finish number 8. Let's figure out what we get for number 8. Okay? When I FOIL this out, what am I getting?
H squared plus 4h.
Okay. H squared plus 4h plus 4, right?
Yeah.
That's FOILing first item and last in no particular order. The next part, I'm going to distribute the 2 to both parts back here. That's 4 plus 2h, and then a plus 3. Right? Does that make sense, like I'm doing that? And now let's simplify. What do we get total? We have, what, an h squared
Plus 6h plus 11.
plus 6h plus 7?
11.
11. Oh, I forgot the extra 4.
Oh, you so
So I didn't even see that extra 4 sitting there. All right. Okay, so there's number 8. That took the longest, right? FOILing it and everything. Number 9 is an easy one. You're just going to go to the original problem.
11.
Yeah, and plug a 2 in. So that's pretty easy. So taking the original problem, plugging a 2 in, should get 11. Well, that's easy, right? That's a very simple thing. 10, you're combining both answers from 8 and 9. So 10 should not take you very long. You're taking the answer from number 8, and you're subtracting the answer from number 9. So I'm taking the h squared plus 6h plus 11, that's the answer from this part, and I'm subtracting the 11 from the second part, so what happens?
The 11's.
The 11's cancel. So it's h squared plus 6h. Does that make sense? Like, it will be something like that on the test day. If you recognize that problem, it was one that we did in the homework ones.
Yeah, I remember.
It's going to be something very similar. It's one of the homework problems that you did. Okay. Questions? All right. Let's move on to number 11, and so on and so forth. All right. Oh, I might try to give you a little more space, but I want to keep this one page, so I don't want to make it too big. All right, number 11. I got to zoom out a little bit. Okay. So, number 11. It's got a series of like multiple questions here. It wants to know: does this graph have an inverse? Why? Is this graph even or odd symmetry? Yes or no? That type of thing. And then find the intercepts on this one. There's a couple different intercepts. There's x and y intercepts. So it's kind of identifying parts. And then the last one is graph that thing, but do a transformation to it. That's what this graph is for down here. Take that and graph it in a new location, right? So those transformations are the thing we're going to talk about. It's going to be something easy. Like, I'm not going to make it super stupid and difficult. It'll be something that you can do pretty quickly. The only thing you're going to need to know, that probably something I'll have on the board, is the order you need to graph. That'll be something I'll have on the board, like where you have to do horizontal shifting first, then you have to stretch or shrink, then you have to reflect, if there's any reflections, and then you have to vertical shift it. Okay, does that make sense, like what we're doing here? Like, they should be like somewhat easy. Okay, so, number 11. Does this function, this graph, does it have an inverse, yes or no?
No.
No, let's explain why. So this is a no. Why? Well, it's not, it can be inverted, but why can it not be inverted? What did we talk about in class? What makes this thing fail? Yeah, horizontal line test. It failed the horizontal line test. That's really all you need to say. Fails horizontal.
What is that?
Horizontal line test. It's what, if you look at your textbook, it's a test that tests whether your graph can be inverted. That means if you have your function y equals x plus 3, and you switch the x and y around, could you resolve it? This graph I'm giving you cannot do that, because it literally has a curve. It failed the horizontal line test. When I draw a horizontal line anywhere, did I hit the graph more than once? Yes, so it failed. That means it will fail this. I won't be able to switch letters and get to a final answer. It probably has radicals or something in it that I can't do it, because I'll have plus or minus answers. Okay, questions? So failed the horizontal. That's literally the explanation. Yeah, just my drawing that kind of showed it. Now, is this graph even, odd, or no symmetry at all? That means as I go from the x-axis this way, x-axis this way, is it the same graph, the right and left side of it?
No.
So it failed symmetry. It's not symmetrical. Not symmetrical. You just circle it out. I don't care. How do you know it's symmetrical? Even looks like this. The graph is the exact same graph right and left. Odd symmetry is where it's the exact opposite. Where like it's up over here, down over here. Like it's the exact opposite. That thing was not balanced the right and left side. It's not even the same graph. Does that make sense what symmetry is? Like I can just look at the picture and tell if it's symmetry or not. Okay, intercepts. We gotta find x-intercepts, y-intercepts, all that good stuff. So is there an x-intercept on this graph?
Yeah.
Give me them.
0.
0, 0, and -3, 0. Those literally cover your x-intercepts and y-intercepts. You can just put them all down. So if you have multiple y-intercepts, maybe it came back over itself or whatnot, you can list them all out.
Wait, so that's asking for the graph as is?
As is. The intercepts for the graph, as it sits. Is there any intercepts?
That's confusing because it says for the following information.
So. Oh, you're right. We have to transform. Oh, you're right. I didn't see that. We'll come back. I might take that out. I might just have to do the intercepts for the original graph. I'll put it in there and I'll.
So was that all wrong with all the stuff we just did?
No, just for that one.
Yeah, just all wrong, I mean.
No, just for that one. Sorry, I didn't see
Only
the
your-
following the transformation. Sorry, thank you. Good catch. All right, so let's do the transformation of this graph, and then we're going to see if it has an x-intercept or not. Okay, so let's talk about what are these things doing.
It's going up to.
Up to, okay, we know that.
The right 4.
Right forward. Okay, so here's how we're gonna do this. We're gonna move to the right and left first, because it's horizontal, then we're gonna move it up and down. If there's any negatives or anything like that, we'll do the flipping later, like that would be after we move it right and left. So we're gonna take this graph and move everything to the right. So I'm gonna do these kind of one at a time. So I know it's gonna seem really weird, so what I'm about to draw, I'm gonna change here in a second. So I'm gonna put it in like a red, and then I'll change it to a final black. So all these spots are going to the right 4. So I'm at -3 right now, it's gonna go to the right 4. Okay, 1, 2, 3, 4. So there's that left dot. This dot was at -2, -4. And now it's going over 4, 1, 2, 3, 4. So there's that spot. And this spot was at 0, 0, it's going over 4. And that spot was at 1, -4, it's moving over 4. 1, 2, 3, 4. Okay, so here's what the graph looks like. Okay, when I moved it to the right. Does that make sense? It's not my final answer. That's just moving that graph to the right 4 spots. Now, what's the last thing I have to do? Up 2. So this will be my final answer. I'm going up 2. This spot goes 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 up 2. Here's my graph. so now what you're gonna do is you're gonna tell me the intercepts roughly where they're sitting, like guesstimations, okay? So where is this spot roughly?
1-0.
Yeah, I'll say that's close enough, 1, 0, right? You just have to be within the ballpark. I know it's not exactly 1, 0, it looks close. Where is this spot?
2.53.
This spot is 3.30,
30.
or
That's definitely 3-0.
Yeah.
1, 2, 3, 4, 0, you mean?
No. That's not mine.
No, it's 3, 0.
No,
Did I-
that's mine only 2.5.
Did I go too close?
Yeah.
Okay, so 3, 0. My drawing's really bad, so you'd probably want to draw a little more accurate than I
But
am.
you went over 4 and it was at 0 before.
So over 4. Up
Yeah.
to.
You went
Up
up,
to.
you went up 2, that's not how that works.
So it's about 3.5 roughly. Close.
Unless you're absolutely sure what you're
Okay.
going to say.
3.5. I'm gonna go 3.5, 0, whatever. It's close. And this spot right here. What is that? 4.5, 0.
1, 2, 3, 4. That's definitely 5.
5. Okay.
5.
You gotta be in the ballpark. Okay. Be in the ballpark. Try to figure out roughly where it's at.
But how big is the ballpark? Like how much you know how to go?
Usually, if you're within like a half or like one dot of it, like if it's in the ballpark, I would give it to you.
So like
Now, here's what I'm going to tell you right now. I'm probably going to just do it on the original function. So it's just real quick, you can just read off right away.
Are you gonna have like those kind of transformations? Are
Yeah.
you gonna have like the stretch, the shrink?
I'll probably have something like this. I could definitely throw in a reflection, like right there on negative. So if I throw like a negative out front, that graph is just flipping over to the other side. If I throw it on the inside, it's flipping like this way. You have to do that after you do the horizontal shift.
Don't do that though.
So that's what I would expect. I'm probably not going to do a stretch, just because that's super difficult to figure out. Like when you're just like guesstimating where these things are falling.
What's the horizontal clip and
What?
what's the...
I said if we don't do that, that'd be like totally okay.
What? What was the other question?
What's the horizontal clip and what's the...
Going across the x-axis, like going down, is when they throw a negative sign outside. And if you want to go across the y-axis, you put a negative sign on the inside with the x.
Wait, can you rotate it?
No, there is a rotation. We're not doing that.
Well, what is that? What would that look like?
You would have to find every
On the
coordinate.
function though.
There's 2 types of rotation that we have right now. We have a 90-degree rotation or a 180-degree rotation. You'd have to find every individual coordinate, and you have to go through like a, you have to go, hey, no touching that. I already told people that.
Oh, you sleep
No touching that. I already had problems with that yesterday. Don't. I don't want to give you detention. I'm not joking. So, okay, we're moving on.
You never. Okay.
So what
You
would
should
you have
definitely throw
done?
it in there.
What?
What would you have done if you had fell?
What fell?
Oh yeah, Lucas
When you jumped over that.
Alright.
Someone poured
Alright.
Thanks for answering my question.
He came back and he was all over.
Don't care. All right, moving on. Number 15. Okay, we have to do logs of both sides, either natural or whole logs, or natural or just regular or like original logarithms. So here's the idea. To do a logarithm on this one, I'm just going to take the log of both sides. Now the reason why I'm doing that is because I have numbers and I don't have any naturals. So I'm going to drop the x out front, and then you'll divide by this log of 17 over. On these, I want the exact answer. I do not want decimals. You should not need a calculator. You can stop after you divide the log 17 over, then move on to the next problem. Does that make sense?
Log base 17 too.
What?
Like if I wrote log base 17.
You're fine, yeah, because when you divide that over, I agree, like log of 2 with a divided log 17, that is the same as this, log base 17 of 2, I'm fine, because that's the same, that's a change of base.
Good deal.
Because that 17 comes
I
out,
was confused on how I drew that.
so you're solving for x. All right, on this one, you have to solve for the x, but it's on an e. So in this problem, I'm going to divide the 5 over first,
Gives you the log natural.
and now we got to do the natural log, yeah? Because we have an e on this problem, so we have to do natural logs. So natural log of this, natural log of this, we'll drop the power out front, we'll divide over, and that's your answer. Don't give me a decimal, you should not need a calculator. I want the exact answer, no decimals required. I know on the first page you have to do a lot of decimals, this page you don't. Questions?
L and E.
So this literally will cancel, and then you can just solve for x. Yeah. That's the beauty of doing that.
Wait, so do you divide the 5 first?
Yeah, you have to, because you have to get the thing with the power by itself. So that's why I have to get the 5 over first.
So can you finish it with that one?
Nope. Divide it over.
I don't know what you mean by divided.
Literally divide 0.2 over.
Oh, that's
Get it
It dropped out as the power rule.
Duh.
The natural like is gone.
whatever you want.
Just
Done
divide
that.
it over.
Do I keep the X on the right?
So that'd just be 7.
That
Alright.
would not just be 7.
Okay, moving on.
2 is.
Alright, 17. You have to draw. Now, I already had the question yesterday. Ward, are you going to do a horizontal shift to us on the test?
7 is.
No, I've already promised you I'm not doing that. Practice test, I didn't promise you that. So, this one, we're going to have to horizontally shift it. It is a sine, I'm going to tell you right now, it's going to be a sine or cosine graph. I'm not going to do a tangent to you because we only talked about tangent, we didn't really do any in the homework. So it'll be a sine or cosine graph. It'll be a simple amplitude, period, up and down shift. No horizontal. Now I've picked a horizontal here, so you get some extra practice at it, even though I'm not assigning it for the test. So on this one, typically, on this one, I would figure out the period length first. I know that it's shifting up 8 and the amplitude is -4. Like I know the wave's really tall and it's actually like upside down because of the negative sign. Because technically this 8 would, when I do this, usually I put the 8 in the back, like a +8. That's kind of what it normally is. So, I'm going to figure out the horizontal shift first. Normally we go out to 2 pi. That's like a normal thing. So that's pi, pi over 2, 3 pi over 2. So that's usually what we're doing. The problem is, this is preventing me from doing that. We're not going exactly, we're not going over to 2 pi. We're going to start at a new 0. My new 0 is where I take the 2x plus pi and set it equal to 0 to figure out where I'm actually starting. I'm not starting at 0, 0 anymore. So when I solve this, I'm going to subtract the pi over, divide the 2 over. This is my new 0. That's the new 0. So really my graph is starting here at negative pi over 2. That's where my graph will start and do the sine graph.
So we don't have to do that, right?
Correct.
Wait, why is it
Test.
on the practice test if it's not on the test?
Because I want you to get more practice with it. So you can see it.
Because where's the
So,
special kind of
But
It's
now I
gonna
don't
be
know
on
what
the
the
next
special
test.
test.
I mean, I can stop you and do it by yourself. I'll grade it.
I'm just
Never
confused.
mind.
Well, you never did 17 with, or 16 with us.
That one's not that off.
I actually don't really know.
17 was literally a homework problem because you didn't do your homework.
I'm getting there.
All right. So number 17. So I figured out where 0 is. Now, to figure out all the hash marks, normally I go out to 2 pi, but since there's a number in front of my x, I have to divide by it. So that's what I normally do to figure out period length. So this will divide and make pi. So that means that instead of going up to 2 pi, it would technically normally be now pi, right? Now, I'm coming back to this idea here in a second. So, do you agree that we have a number in front of x? Normally, we always take 2 pi, divide by that number. That tells me what my 4th hash mark is. I cut that in half. I cut that in half. I multiply that by 3. So here's the idea, right? That's usually what we do. Okay? But the problem is, did I start at 0, 0? No. I'm starting over here at negative pi over 2. But you are still going to use these hash marks. The way that I wrote it right there, those are going to be my hash marks that I'm going to use to get to these next few spots. These spots. These 4 hash marks. And I know exactly where they're landing. I actually did that right because if you watch, what's the first one I have to add? Pi over 4. It's negative pi over 2, adding pi over 4. That's the first hash mark. I'm adding this space to where I started. That's where the first hash mark is. If I go to the next spot, I add the second hash mark, negative pi over 2, right? That's where I'm starting here. And what's the second hash mark?
Pi over 2.
What's negative pi over 2 plus pi over 2?
0.
That's marvelous.
Then I go to the third spot. It's the starting point, negative pi over 2, and I'm adding the third marker, which is 3, 5, or 4. Does everyone see how I'm getting each of those hash marks? You don't need to give me the decimal. I know some people like, oh, give me the decimals on each of those. But each of these numbers would represent where that hash mark lands. And the last one you're adding 5.
I don't like this.
Okay, so there's my 4 hash marks.
How do you know where the hash marks go?
It's based on, if you want to know like exactly where those hash marks are, I would type those in a calculator, like add them, and see if am I landing in the positive, am I landing in the negative. So, but yeah, my numbers are easy because they're landing like nice clean spots. So now, I am going to shift it up 8. So this midline is now, if I'm shifting this up 8, I'm just going to say this is 8. Like that, I'm starting at 8, I'm just going to do that weird shift. So it's not, this is not 0, 0 anymore, it's like up 8. And how far above it and below it am I going? 4 and 4 this way. So I'm going to actually hit 9, 10, 11, and 12. 7, 6, 5, and 4. Right? So I'm hitting those numbers. Now, here's the goofy part. I'm drawing sine, but I'm drawing negative sign.
Oh my god.
Because there's a negative out front. So, starting here, we're going down to its lowest point, because its sign is going opposite. Usually I go up and then down. So I'm going to its lowest point, coming back to 0, going to its highest point, coming back to 0. So it looks like an S. It's just doing the opposite. Normally the sign goes up and then comes back down. But we had to go the opposite way because the negative sign is out front.
Oh.
It flipped it over across the x-axis. There you go.
Doozy.
Now, the things you should expect to do. Amplitude, fix the period, and then shift it up or down. Do not expect a horizontal shift. I threw that at you because I promise you it wouldn't be on the test, but I promise you on the practice test.
Oh boy.
You got us.
They get you.
Your words there, Mr.
So you know it's a horizontal shift that putting pi